All right, let's do a masterclass recap on first-order linear differential equations. We're not just going to solve a few problems today. We're going to build a solid, foolproof blueprint. This is your guide to nailing these equations, so you get the right answer every single time. Let's dive in.
But hang on. Before we lay down the first piece of our blueprint, let me ask you something. What do you think is the #1 mistake that trips everybody up? I mean, even the sharpest students. Is it some crazy complicated integral? Forgetting the plus c? Well, the answer is actually a lot simpler, and it happens way earlier than you think. You know what it is? The most common mistake has nothing to do with calculus at all. It's algebra. It happens right at the very beginning, before you've even thought about taking a single derivative or integral. It's a fundamental slip-up, and it's exactly why the first step of our blueprint is also the most important one. And that brings us to the absolute bedrock of this whole process, the unskippable first step. Seriously, think of it like the first domino. If you get this wrong, everything else that you do is just going to topple over. And this step is all about putting the equation into what we call standard form. Okay, so this right here, this is the golden rule. Your equation has to be in this exact format. And the most important part, the part everyone forgets, is that the coefficient of dy by dx has to be 1, just 1. This is totally non-negotiable because it's the only way you can correctly identify the two key players in this whole thing, p of x and q of x. Look at this slide. This shows you exactly why it's so critical. On the left, it is so tempting to just glance at that and say, oh, p of x is 2x, right? But that would be a huge mistake. To get it into standard form, we have to divide that entire equation by cosine of x, and only then, on the right, do the true p of x and q of x reveal themselves. So let me be absolutely crystal clear about this. Do not, I repeat, do not even think about picking out your p of x and q of x until your equation is perfectly in standard form. Trust me, this one simple habit will save you from making the #1 mistake. Okay, so once you've got your equation set up correctly in standard form, you're ready for step 2. Now we're going to forge the master key that's going to unlock this whole puzzle. This key has a name, the integrating factor. And it is a seriously clever piece of math. So what does this key actually do? Well, the whole point of this integrating factor, which we call I of x, is that when you multiply it through your equation, it magically transforms the left-hand side into a perfect product rule derivative. Now, it seems like magic, I know, but it's just really smart design, and it sets us up perfectly for the next part, which is integration. And like I said, it's not magic. You can see right here where the formula comes from. It all starts from what we need the factor to do. From there, we just separate the variables, integrate both sides, and solve for our factor, which gives us the general form for our master key. Now, wait a second. You probably see that c from the integration, and you're thinking, wait, aren't we always supposed to keep the plus c? Why do we get to just say c equals 1 here? That's a fantastic question, and the answer is actually pretty cool. The answer is really simple. It turns out that any non-zero constant you put there will work just fine as an integrating factor. That constant would just get multiplied through the whole equation and cancel out later anyway. So to make our lives easier, we just choose the simplest constant there is, 1. And that leaves us with this clean, elegant formula for our master key. I of x equals e raised to the power of the integral of p of x dx. This is a huge part of the blueprint, so you'll want to get really comfortable and fast at calculating this. All right, so let's do a quick check. Is our equation in standard form? Yes. Have we forged our master key, the integrating factor? Yep. Now it is time to put all the pieces together and execute the final stage of the blueprint, finding the actual solution. And the process from here is really straightforward. First, you take your integrating factor and multiply the entire equation by it. Then, by design, that messy left side just collapses into the derivative of I of x times y. Next, you integrate both sides, and please, please do not forget the constant of integration here. Finally, just get y by itself by dividing everything by I of x. And speaking of that constant c, this is probably the second most common mistake people make, and it's a big one. When you go to solve for y in that last step, you have to remember that the constant, c, also gets divided by the integrating factor. So many points are lost just by forgetting that simple step. And here it is, the whole blueprint in one single formula. The solution, y of x, is 1 over the integrating factor, all multiplied by the integral of I of x times q of x plus c. This is it. This is the culmination of the whole process. So, we have this really powerful blueprint, which is great, but what gives us the confidence that it's always going to work? Is there some kind of guarantee? Well, yes, there is. And it comes from a really important theorem in differential equations about existence and uniqueness.
It really just boils down to this. For a solution to be guaranteed to exist, our two functions, p of x and q of x, have to be continuous, no breaks or jumps. And for that solution to be the only one possible, well, that also depends on p of x being continuous. For us, that means as long as p and q are well behaved, we are good to go.
So, what does this all mean for you in practice? It means that as long as those functions in your equation are continuous on some interval, our blueprint is absolutely guaranteed to lead you to the one and only one correct solution for any initial value you're given. This isn't just a nifty trick, it's a reliable method you can totally trust. Okay, let's wrap this up. We're going to distill this entire blueprint into a simple mastery checklist. Think of these as the key habits that will take you from just getting the right answer sometimes to truly mastering these equations every time.
First, and I can't say this enough, standard form. First, always, no exceptions. Second, get fast at computing that integrating factor. Practice it until it's just muscle memory. Third, do a quick little sanity check for yourself. After you multiply by I of x, just glance at the left side and make sure it looks like a product derivative. And finally, if you're dealing with an initial value problem, don't forget to state the largest interval where your solution is valid.
So I'm going to leave you with this final question. You have the blueprint now. You know the steps. Be honest with yourself. What's the one weak spot in your foundation that you need to fix? Is it remembering to always check for standard form? Is it getting faster at integration? Or is it remembering to divide that c by the integrating factor? Whatever it is, identify it, drill it, and you will master this blueprint.